What we're going to do is we're going to go over the concepts we talked about in class for explaining the ranking that we give things in terms of the different trends. And this is going to be almost exactly like what we did discuss in class, or one of the examples, because it's meant as both a review and just a reminder of the steps. Because remember, the key for answering these questions is to ensure that you include all of the parts. So for this, we're going to look at first ionization energy, which is the easiest one, and we're going to rank them and explain using using the appropriate terminology for potassium, lithium, and nitrogen. So remember, our first step when we want to answer these types of questions is that we have to define the term. So here I define ionization energy as the energy associated with removal of an electron. And I can even give the equation if it's appropriate. Step 2, we state that what the force of attraction is related to. Remember what I said, this is key, stating this, because this is what we're building our argument on. We are going to be using this relationship for our ranking. Now, to be able to use this effectively, we have to have an understanding of how a change in ENC will change my force of attraction and change of distance. But also, we have to do the third step, where we relate the force of attraction to the trend that we're looking at. So here we're saying the greater the force of attraction between an electron and a proton's nucleus, the more energy required to remove it. So now we've laid out our argument, and more importantly, we have this relationship, because we're going to be talking about the rankings in terms of differences in our ENC or distance. Step after we've defined our term, stated what our force of attraction is due to, linked our term or trend that we were looking at to force of attraction, is to then start doing comparisons. And when we do comparisons, we want to compare all the things in a group, and then we want to compare things that are in a period. So lithium and potassium are in the same group, and as a result they have the same ENC. And because they're both in group 1, they have an ENC value of 1. The difference between them is the distance between the nucleus and their valence electrons. Potassium being in group 4 will give a distance value of 4, and lithium being in group 2 will give a distance value of 2. Since the force of attraction is inversely related to the distance squared, and potassium has a greater distance, it'll have a lower attraction than lithium. And with lithium's lower distance, it'll have a higher force of attraction. So since there's a lower force of attraction to potassium's valence electrons, less energy is required to take the electron from potassium than lithium. So therefore, lithium will have a greater first ionization energy. Our next comparison would be between nitrogen and lithium. Now we know that they're both in the same period, and so as a result they're going to have the same distance and, more importantly, the same number of core electrons. What this will mean is that as we move across the period and we're adding more protons to our nucleus, our ENC value will increase. Nitrogen therefore ends up having an ENC value of 5 because it's in group 5, whereas lithium has an ENC value of 1 because it's in group 1. Since nitrogen has a greater ENC value and force of attraction increases with ENC value, nitrogen has a greater force of attraction than lithium. This will mean that because nitrogen has a higher force of attraction, it requires more energy than remove an electron, giving nitrogen a greater first ionization energy than lithium. Once we know have done all of our comparisons, our final thing to do will be to rank them. And so from our ranking, since lithium was greater than potassium, potassium was the lowest first ionization energy, and since nitrogen was greater than lithium, nitrogen has the greatest, with lithium